All right. Hey there. Okay, so welcome to the Timeline talk. Unless you've used Timeline before, or I suppose Kibana, or kind of follow the Elastic blog, you probably have little idea what this is about. It's not a terribly descriptive talk title, and so I'm sorry for that. And I'm going to tell you all about what the talk title is about. First, I'm going to tell you all about who I am, because that'll give some amount of context to this. It'll also help me get out some frustration and give you some understanding of how this talk came to be and how the project ended up being what it is. So, my name is Rashid Khan. I work at Elastic. I wrote the first couple of versions of Kibana. Kibana is now written by a whole awesome team of people, which is great. It frees a lot of us up, me and other people at the company, to do little experiments. And so Timeline was one of my little experiments. I started working on it a little while ago. We'll get to that. If you need to get a hold of me, these are the ways. Twitter, GitHub, and given the Twitter and GitHub context, I bet you can guess how to get a hold of me on IRC. Okay, which is, by the way, the best place to get a hold of me. I've been terminally addicted to IRC for the last 20 or so years. Okay, why am I here? Well, to tell you why I'm here, it's probably somewhat important to tell you where I was. Has anybody gone to a GoTo conference before? No? Okay, well then, GoTo, not terribly dissimilar to DevOps, very developer-focused conference. I was at the one in Amsterdam, and I was giving a demo of Kibana. And I found myself terribly frustrated when I was putting together the demo, because I was trying to I was doing some use cases, and a lot of times I give like here's how you do logging with Kibana talk, because that's what I know. I've done operations for a really long time. I know logging, but I wanted to focus on something a little bit different. Specifically, I wanted to explore some time series cases, and that just didn't work out super well. And so that's kind of why I started writing Timelion. Although it's not really why, nor is it really when I started writing Timelion. You see, there was a problem with the when. I couldn't write it at the conference. I still had to give the talk, so I gave the talk and that went fine. But I still needed to come up with some way to give the talk that I wanted to give, which was the one all about time series and what you can do with Elasticsearch and how you can bring in other sources of data, which is super, but I didn't actually have a tool that could accomplish this, nor did I have basically any of the time to write said tool. I did have a lot of time to go to deal with emails and to deal with meetings, and I had plenty of time to make lots of excuses as to why I had never written this thing. What I didn't need was emails, meetings, and excuses. What I needed was some time to write some code, which really meant I needed to get rid of that, just for a little while. I didn't need very long. I'm sure everybody here has worked on some project where they found that most of their time in getting started writing the project is getting started writing the project, finding 2 hours or so to just work. So I needed to find a few hours. Fortunately, I had a plan. More specifically, I had a plane. Specifically, I had a plane from the Netherlands to the States, which is much longer than the 2 hours I thought I would probably need to at least get myself into trouble. So I resolved to figure this out on the plane on my way back. Best part about flying from Europe to the United States is that it's basically daytime the entire time. So you've got this extra long workday where nobody can get a hold of you, which is, for me, great. There is one other issue with the whole no email on a plane thing. There's no Wi-Fi, and I have to download everything before I leave, which is fine, and actually it turns out to be a great way to start a project. I can't tell you how many projects I've tried to start that I've failed because my first thought is I really want to do this thing, and my second thought is this is a great time to explore a whole bunch of new technologies. So I spend all my time learning whatever the newest framework in JavaScript is, which nobody cares what the newest framework in JavaScript is. And then eventually I get frustrated with whatever the newest framework in JavaScript is, and I just give up and go back to twiddling my thumbs. So I also resolved to not try anything new. Instead, I just decided to try some old stuff. which we'll get to. I'm going to tell you what Timeline is, what it does, roughly how it was built, and where it's going from here. Okay, so that covers the why. The why was basically I wanted a way to deal with time series in Kibana. I wanted a new way of figuring out how time series worked just for myself. And the other why was that I really wanted to explore a language for Kibana. For those of you who have used Kibana, Kibana uses Lucene query string syntax, which is great, but it really only solves the search case. So it can basically find individual documents, and then Elasticsearch's aggregations can deal with making those a little more understandable, right? If I'm searching through a billion things, I don't actually want back a billion records. I want, what the highest value in the billion records was, or how many of those occurred over time. I don't actually want them all back, but Lucene query syntax can't do that. All it can do is find stuff. So I wanted to explore a language that could do a little bit more. But I didn't want to solve the whole problem, right? Like, there's a lot of stuff that Kibana does. My goal was time series, so I scoped the language to time series. So what did that end up looking like? Okay, so I'm going to give you a bit of a demo of what Timeline is and how it works. We'll talk about kind of the language and some of the issues with time series. It's not super complex stuff, but there's a few interesting issues with time series. So let's take a look at it. Okay, so this is your basic time series chart. There is literally nobody in this room that hasn't seen one. This is probably the most common style of chart that you've ever seen. It's what happened over time. You've probably seen about 20 of them today. I know you've seen 20 of them today because I've walked around the vendor area and everybody's got one of these things. So what are some of the issues that we deal with in time series, specifically issues that I've dealt with trying to get Kibana to do it? So one of the biggest issues is simple things like derivatives, right? Everybody knows what a derivative is, right? It's basically, I saw a couple of no's. So derivatives are basically just how things are changing, right? So imagine, most people here have used MySQL. You've probably seen MySQL stats and things like that. MySQL keeps a counter of how many queries have come in. It's just a counter that's constantly increasing. If you want to know how many queries per minute it's doing, it doesn't supply that. It just supplies a counter. So what you need to do is read what that value was at every minute and then calculate the difference, right? You've got a constantly increasing line. You want to see how fast it's increasing. That's a derivative. So fortunately, we can do that with this. In this case, I want to see, let's see, I'm looking at how many things happened per day here. So I want to see what the difference in each day was. So was today higher or lower than yesterday, right? This is a really common thing in operational cases. Am I doing about average? Are things changing rapidly? Is there a lot of volatility, or are things pretty stable? So let's find out. So I should make this bigger. Not too big. Okay. I think everybody can hopefully read up there at the top. So I'm using the .es function. So this is reaching out to Elasticsearch. And here I'm querying Elasticsearch for everything. Functions always start with a dot, followed by a letter of some kind, and then we put the arguments to the function in parentheses. Basically, the parentheses are the invocation of the function, like basically every programming language. And I'm going to, so I've already said it once. Feel free to call me out if I do it again. I try desperately not to call this a programming language because it sounds complex, and it's not a programming language. So the way these work is that you type it in, and this function is a data source function, which means that it can start what I call a chain. So we start here, and we fetch the time series out of Elasticsearch. Now we have a line, and we can start modifying it. For example, I can pull the derivative of this line. Okay, so this shows me how the line was changing over time, so we can see that we experienced a time of high volatility, followed by very low volatility. Now this tells us nothing about the absolute values that we were experiencing, but it tells us that things got calm for a little while. Of course, if we look here, the reason that things got calm is that something horrible happened and nobody came to our website for a long, long time. So that's an issue. So derivatives are useful for figuring out how things are changing from one period to the next, right? So in this case, I'm looking at day to day. If we extend this out to, say, weeks, we can still see how things are changing week to week. But this brings up a problem. If I go back to day here, I rarely want to see in a, say, operational case how things are changing day to day because things tend to go in week-long cycles. I worked for a newspaper, a particularly crummy newspaper. It wasn't that bad, but suffice to say, nobody read it in their off time from work. They really only read it when they were bored at work. And it was really obvious from our traffic graphs because everybody came in the morning at like 9 a.m. and our traffic went way up. Right before lunch, our traffic went way up as people were getting ready for lunch. And then right at the end of the day, it went way up when everybody was ready to go home and they just kind of checked out. Which also means we got very little traffic on the weekends. So comparing Monday's traffic to Sunday's traffic is basically meaningless for us. What we need to do is compare Monday's traffic to Monday's traffic, which a derivative isn't going to accomplish for you. What you need here is a way to say, go grab last week's data for me and treat it as if it was happening now. So let's do that. I'll just get rid of this for now. And I'm going to call .es again. And again, we'll just look for everything. And then I'm going to use the offset parameter. And I'm going to offset this by 7 days. And the offset parameter is available for every data source function, no matter what it is. People implementing data source functions don't need to implement that argument. The Timelion wrapper will take care of that for you. Okay, so great. That got me what was happening a week ago. So now, if I wanted to do something like, say, what's the difference between this week and last week, right? This Monday and last Monday. How would I get that? I would subtract what happened last Monday from what happened this Monday. So let's do that. So instead of putting a comma here, by the way, these are optional. You can do commas or not. In fact, they're optional just about everywhere. Commas or not. I like them because it makes it easier to read. All right, so here I'm going to do a subtract, and I will take that, and I'll just subtract last week's from this week's. Okay, so that'll give us how things have changed from Monday to Monday, Tuesday to Tuesday, Wednesday to Wednesday. And of course, you can do this with weeks and months and all that good stuff. So yeah, this basically shows that there's two ways to accomplish that diffing sort of thing. And actually, with time series, there's two ways to accomplish a ton of stuff. I guess it's kind of like any programming language. Did it again. But there's different ways to accomplish all sorts of stuff. So actually, let me start a new one of these sheets, and I'll show you what I mean. Okay, so I'm going to add a few of these charts. By the way, you can't just do one big. You can do one big one. You can also do a bunch of little ones, and I'll show you why that's neat in a little bit. So here I'm going to look at a different index. For now, I've just been looking at everything in Elasticsearch. We can also specify specific indexes. So I'm going to say instead here I want index equals, I think it's called transactions. Let's find out. Oops, wrong one. Let's move that. Let's move that one. Stick it up there. Okay. So instead, I'm gonna reference an index called transactions, and transactions is this is bank data from it's from an animal shelter. They take in donations and then they spend the money on things like cat food and I don't know, cat food, I guess. Okay, so this is all of their transactions. So right now we're just getting a total of how many transactions they did, which isn't super useful. What's more interesting is, say, what their bank balance is. So I'm going to pull out their bank balance. This can do more than just count events. It can dig into specific fields. So here I'm going to pull a metric out of Elasticsearch, and I'm going to get their minimum of the balance field. Okay, so that's ugly. Okay, there's a reason that's so ugly. So this is their balance over time, but there's a bunch of gaps, right? And the reason for this is that this is basically their transaction data. Now, when you go to get your transaction data from the bank, it just shows you all of your transactions. It doesn't have a it doesn't have a line every day, right? It's got you spent $20 and now you have this much money in your bank account. And it's the same deal here. So we've got some days that don't have data for them. And so when we're pulling back the time series doesn't know what to do with days that don't have data. It just says, look, there's no data. So we need to tell it what to do with the fact that you don't have data on those days. And there's a few different ways you can handle that. Let's think for a bank balance. For a bank balance, we can make the assumption that if we didn't do any transactions, then my balance today was probably the same as it was yesterday, unless there has been some horrible financial collapse. So I'm going to use a function in Timelion called fit. And fit basically says, fill in the null values for me using some algorithm. And the list of algorithms is here. We can use average, carry, nearest, none, and scale. Don't ever use none. A, it doesn't do anything, and B, there is one place it does do something, and we'll get to that later, in which you definitely don't want to use it. Okay, so I'm going to say carry, because carry will just take whatever the current value is and keep that as the current value until it changes. Okay, there we go. So that fills things in for me. But there's another way to figure out what their balance is at any given time, right? If we think about a balance is basically just the sum of the transactions we've done, right? So if I deposit 100 euro and I take out 50 euro, I've done one deposit, I've done one withdrawal, and I have a balance of 50 euros. So we can do the same thing with this. So I'm going to copy this over, and I'll move it to this chart over here. So what I can do is I can say instead, I can get rid of the fit here, instead of their minimum balance, I want the sum of the amount field. Okay, so there is the sum of the amount field. And this basically just says, how much did I spend on each day? Well, if we add up the sum of what we spent on each day, and of course that includes our withdrawals and whatnot, then we've got what our balance is. So let's add them up. All right, so now we have a cumulative sum, which those two charts look awfully alike, except that they have slightly different bounds. One of them starts at 861. So we can also add 861 to that one, and now they're exactly the same. In fact, there's other ways to end up with the same chart in Timelion, besides just picking out two different fields. For example, I could, let's say I just wanted to use the data from this chart. There's a thing called references in Timelion to accomplish that. So I can go @2. And this will go and fetch the data from that chart, which is nice because say I wanted to keep a reference or something. I've got a reference set of data. I've got something that I'm always changing the query on, and I want everything else to use it in its calculations. Because I can use this for calculations. I can throw this in parentheses, and now I can start to use it. I can, divide it by, 3 or something, and make it smaller. Or I can run a cumulative sum of that, and it tells me the totals that they've been, the total balance. It's a pretty useless number, frankly. But anyway, yeah. So there's a bunch of different ways to get these numbers, and there tends to be just a bunch of different ways to do all sorts of stuff in Timelion. And what we're often looking at when we're looking at these things is the shape of stuff. And I'll give you an example. I'm going to switch back here, and I'll just give you an example of what I mean by we're often looking at the shape of things instead of like the absolute bounds of the chart. Does anybody know what their highest balance was? It's not on the screen anymore. Right, nobody looked at it. All you were looking at was the shape. And that tends to be true in basically most time series cases. When you've got a big board up on the wall and you're trying to make decisions based on your charts, you're usually not looking at the axes marks, right? You're looking at how the chart is changing. So if it continued a straight line and then went like this, something is either horribly wrong or horribly great, and you should probably find out why. But there's kind of an issue in looking at shapes. I'll show you what I mean. This is another problem that I wanted to solve in Kibana. So again, I'm going to start a new one of these. And here, I'm going to just use a nice big chart this time. Okay, so The issue is that if we're looking at basically different scales of things, I'll give you an example. I want to look at all of, let's go back to this other data set I have, which is website traffic. This website traffic happens to be traffic to US government websites. I should put USA Gov there just to make sure it's only that. So this is traffic to US government websites. Whoops. Did I miss something there? Oh, there we go. So this is actually a good point. Things can either be in order or they can be named. So if we look here, this lists what order things go in. So the first thing is the query or queue, followed by the metric, followed by the index. So the reason I got the error was that I didn't name the parameter, and I tried to put it in the wrong format. So here we go. We named index and we named queue. So traffic to US government websites from the US, and let's also do traffic from, let's do Canada. Okay, so here we can see that, well, obviously the US has more traffic, the US has more people, of course it has more traffic, and if we thought of this as like e-commerce data or something, we would make the assumption that we do a lot more sales in the United States. Of course, the US is much bigger, we have to have a bigger sales force. We're really not sure if these follow the same patterns, right? So ideally we want to normalize this kind of stuff. Well, we can do that in a couple of different ways. We could say put this on the second y-axis. That helps. Of course, it becomes a terrible problem when we want to add a third country to this, because of course there's only two y-axes on this. So if we added Mexico, I guess we could have 3 axes. Yeah, that's just irritating. I don't want to try to read that. Again, they're all stacked up there, they're not even labeled. Okay, so that's a bad idea. Let's not do that. Instead, because we don't really care about the axes, as we pointed out last time when nobody read them, let's just munge the data. So I'm going to take off those y-axis things. I'm going to put these in a group. So when I put things in groups in Timelion, basically any function that I execute on that group after this will apply to everything in it. So I'm going to, on that whole group, I'm going to execute the range function. What the range function does is it basically reshapes the series to meet a certain bounds. So I can say range from 0 to 100. And as you can see, each of these has a different range, right? That's 0 to 120, 0 to 600, 0 to 3000. Just make everything 0 to 100 and fit them all on the same chart. And now we can do a much more direct comparison since everything has the same extents. For example, we can see that Mexico had a big spike over here, and over here Canada was a bit higher, and here Canada was a bit higher. This is still hard to read, so what I'm going to do here is I'm going to apply a moving average to this to make it a bit easier to read. Okay, so there we go. We've got nice smooth curves, and it's much easier to read than the very noisy daily data. But this still doesn't really solve all of my problems. So we've gone and we've made these all the same range, but we didn't really address the problem that we had earlier, which is that the US has a lot more people than Canada. And so of course it's going to have more hits. And then this chart still basically shows that, but we've rearranged everything, so we don't really know. We just know that they kind of look similar. What if we wanted to figure out what our market penetration into each of these countries was? So market penetration is basically how much of the market you've captured, right? So you decide the market size, and sometimes your business analyst or something will say, look, you've got this many potential customers, but we'll pretend we're just dealing with a website here, in which case we want everybody. And so let's just consider the entire population of the country. So off the top of my head, the entire population of Canada is, I have no idea. None whatsoever. So let's fix that problem. I'm going to go back to our simple case here, where we just have the US and Canada. Okay, and I'm actually going to extend this out to 2 years. Okay, so now we're out at 2 years. I want to figure out market penetration, so I need the population of the US and the population of Canada. Fortunately, this doesn't just work with Elasticsearch. It works with a whole bunch of other time series providers. And it's entirely pluggable, so you can write new ones, and basically all you have to provide is an array of tuples. It'll figure it out, timestamp in milliseconds followed by a value. It'll just kind of handle it. So there's a time series provider that uses the World Bank API to fill in data that we don't know. I don't have time to keep track of the population of every country, but the World Bank does. Nice of them. All right, so let's use the divide function. And then I'm going to use the World Bank indicators function, which is a terribly long function name. As I pointed out several times, there's lots of different ways to do things in Timeline. So instead of using the World Bank indicators function, which is too long, I'm going to use the WBI function, which is the exact same function, but only 3 letters. Okay, we'll use the WBI function. We'll call up the population of the US. The default for the World Bank API is population. You can also specify other data. They track all sorts of stuff. They track economic growth. They track who in what age ranges are in school. They track pollution. All sorts of neat stuff. My wife and I have sat on the couch for hours digging through interesting problems in the World Bank's data set and never visiting the website, which I'm sure they just love. Okay, let's do the US and Canada and see which has. Okay, so as far as population goes, these are actually fairly close. So again here, if we were to wrap all these up in this, we can do a moving average here and get a better idea of market penetration. And actually, we have a higher market penetration in Canada than we have in the US. We're actually doing better in that market. It's a smaller market, but our resources go further when we stick them in Canada. For whatever reason, we're more popular in Canada. Neat. Not by a terribly inconsiderable amount, right? I mean, if we look at the ratio between these two, it's probably 1/4 or something. We could, of course, find the actual ratio at any given point by dividing one series by the other, but let's not bother. Other data sources besides the World Bank and Elasticsearch include Graphite and Quandl. Has anybody ever used Quandl before? You should check it out. I have no financial ties to them, but I think they're really neat. I only use their free service, which just gives you access to things like stock data, and there's a bunch of them. But they're basically a time series API provider. Super cool. All right, so that's basically how it works. How did it happen? How does the whole thing work? Anybody ever written a parser for a language of some kind before? Oh, sweet. So this should be easy. Peg parser? Haha, score, only 1. Good. All right, this isn't a total waste of time. All right, parsers in JavaScript? Yes, all right, I get to show you something new. Score, all right, so how does this work? It uses Peg.js. Peg.js is a parser generator for JavaScript, which means you don't actually have to write the parser, you just have to write the grammar, and it handles the rest of it. There's ups and downs to Peg parsers. For example, they lack backtracking, but the ups are that they're really easy to write. So let's take a look at it. So we dealt with a couple of different kinds of things when we were doing this. And this is obviously not the entire parsing grammar. I just picked out an important section of it with all the relevant features and kind of where the whole thing starts. So this is part of the actual Peg grammar, and we dealt with a few different things. Mostly we dealt with series types. So I mentioned that a collection of functions is called a chain, right? We also dealt with groups, and we dealt with a reference. When I did that @to thing, that was a reference to another thing. And as we can see, basically everything has to, when we start at character position 0, when we're parsing the string, everything either has to end up being a group of something, which a group can contain chains and references, or it has to be a chain, or it has to be a reference. These are the names of the things in the grammar. For example, this is a chain. So a chain is, a series list, or a series type is basically a group, a chain, or a reference. A chain is a function followed by any number of additional functions. So function followed by any number of additional functions, either none or some. And then basically just returns a plain JavaScript object, basically the plainest. Says type chain, and then it takes whatever the function was and makes an array out of it. And and so basically it takes this, so .es, get everything out of Elasticsearch, divide it by 5, and turns it into this. This is basically the AST that gets generated by the parser. So when you pass a string in, what you get back is this thing. And so this thing is, again, it's a chain, right? It came from here, right? It was basically just that thing there. And this is the body of our chain. That was, if you'll remember, that grayed out part in the return chain, and the property chain is the first function concatenated with the rest of the functions in an array, okay? And so what this does is there's a runner process that basically it takes this big AST object and just runs it through through functions. So as it reads out each part of this, it will grab off it'll see that this is of type chain, and it'll say, okay, what do I do to process type chain? I've got a function to process things that are type chain. And when I get in there, I will start going down this list and basically just unshifting the list. So taking the first thing, rather shifting, take the first thing off the list, resolve that, and then pass it into the next thing. So in this case, it will take the ES function, and it'll get the time series out of this, and then it'll use this as the argument to the plus function in this case. I think I had divide on the previous screen, but whatever. So it'll add 5 to everything in it, and then it'll make lines. Very, very, very exciting. Okay, so that's kind of the basis of peg parsers. And I do encourage you to take a look at it. I think the totality of the plane ride was probably about 12 hours. I think probably the first 2 hours of the plane ride was reading Peg.js documentation and figuring it out. There's a fantastic online test tool for it at the Peg.js website that you can type in your grammar, you can type in what you're going to put into your grammar, and it will spit out the AST for you, so you can kind of develop this thing live. You don't constantly have to recompile or anything. Yeah, super, super easy to learn. Okay, so what now? Well, there's still some improvements that I want to make to Timeline, including things like bringing in support for terms aggregations. But that's not everything that I hope to get out of it. So, like I said, part of my reason for doing this was to figure out how a language in Kibana could possibly work. And so I've also started to play around with that idea. And I'll show you what I mean here. And unless you were in the Birds of a Feather talk with David and I last night, you probably haven't seen this, which is good for me, because it won't completely bore you. But I've started experimenting with other ways to accomplish this sort of thing, other ways to do things in Elasticsearch with the use of a language. How many people in the room have used Elasticsearch at some point? Okay, most. That's good. That works for me. Because I don't need to explain to you that when you put things in Elasticsearch, you have to parse them in some way first, right? So if you've got a JSON object or something and it's got a string in it, have you used logstash before? Okay, great. So we're all really familiar with that grok function, right? Which breaks things down into fields. And of course, we have to do that before we put stuff in Elasticsearch. I wanted to experiment with, well, what would happen if we just wrote a language that just pulls stuff out of Elasticsearch without breaking it up first? What if we didn't need to parse everything ahead of time? What if we could extract fields at search time? So I started playing around with this in a language. So as you can see, this is really similar to the timeline language, right? Everything starts with a dot, everything's a function. But this can do a little bit more. For example, obviously it's showing you things as a table right now, which are a very simple table. It's really just showing you all of the documents account of how many things I have in here, which at the moment is 836,000-ish. We can also look at the actual documents that are in the index, which is a bunch of like Kibana stuff. In fact, let's change this index to be USA Gov here. There we go. That's a little better. Okay, so let's say that I wanted to extract some fields here. Now, I've already got some fields extracted, but what if I wanted to do something like search by domain or get my top domains? Well, getting my top destinations is pretty easy. I can just say top destination. I can say get the top 5 destinations. So there's my top 5 destinations, but what if I wanted to get the top domains? I don't have domain in my documents anywhere. Domain, it doesn't exist here. So let's extract a domain field, and it's pretty obvious looking at this what a domain is here, right? I mean, it's just the part after the protocol and the part before the path, but normally if we're using Logstash, we'd have to extract that ahead of time. So instead, let's use this function called split. And if you've ever used the cut function in Unix, this works very similarly. So I'm going to split from the destination field, and I will split on that slash character. I'll grab at index 2, and I will call it the domain field. And absolutely nothing will change about this table. And of course, the reason for that is I'm still grabbing out top destination. But if we drop over into the docs table now, we can see that indeed we've extracted out the domain field from Elasticsearch, from the destination field. So I'll take this top function. I got to throw it after the split function because, well, we had to split first. And now we'll grab the top 5 domains. There we go. So that works. And this is, as far as you can tell in the language, this is a fully functional field. It works just the same. We can still search for things in it. So we can search for, say, domain is www.nasa.gov. Like, that still works. Presumably, we'll just get back 1. Yep. And, if we go in here, all of these are nasa.gov. That all works. And we can even do other aggregations here. So we can do things like top user to 5 users, sure. So these are the top 5 users. In this case, it's Bitly data again. So these are the top 5 users for the nasa.gov domain. And we can still do a lot of the things that Timelion can do. So for example, if we wanted to pull the top 5 users, and then if we wanted to pull a time series out of this, actually, let me, I don't use this very often. I just kind of like pulled this back up, so I've got to remember a few things in it. I did it last night, so I'm going to make sure I pass this the timestamp field. And then I'm going to pull out a time series, again on the timestamp field. And I guess I should make that more than 15 minutes, huh? All right, so there's the last 90 days. And then I can do things like add another view to this, right? We can still view the documents this is made of. We can view the table that it's made of, but we can also, say, make a chart out of it. So we can add a new view here, and we can go in and change that view from being a table to, say, a time chart. And we can say across my x-axis, put the timestamp, across my y-axis, do the count, and split things up based on what user it is. I think that'll work. Yeah, so there we go. And it can do all sorts of other stuff. You can pull Elasticsearch metrics and all that kind of stuff. This is really just a toy right now. I don't recommend you actually use it. This is just to show you kind of where we wanted to take the idea of Timelion. Timelion is also kind of a toy, right? It was my exploration into time series in Elasticsearch, as well as my exploration into what a language for Kibana could be. It's fully functional. You're absolutely welcome to use it. It's fun. I use it every day. The goal was, of course, to make something useful too. And someday this will also be something useful. Yeah, so that was what's now, what I'm working on now. So what else? What else can I tell you in what apparently is 6 minutes left, which I think they're going to get mad at me if I go too far over. So I'll try to keep this short. What else? So, as you've probably noticed, I haven't been swapping back and forth between, say, Chrome and the browser, or Chrome and Keynote. This is because I am basically incompetent with a keyboard. I've tried to do this many times in many talks where I switch back and forth between demo and a slideshow. I think the process is somewhere along the lines of Command Control F, Command Tab, Alt F1, I think is the way to switch back and forth. I think. I don't actually believe that would work. So I wrote a plugin for Kibana. Timelion is also a plugin for Kibana, but I wrote this plugin which lets you export Keynote slides to Kibana and just load them up in Kibana. This is really helpful for if you're giving a presentation to a group and it needs to be kind of like data driven, like you want to swap back and forth, like you're giving a presentation to your boss or something, and they say, well, what about this number? You can quickly switch back and give them that number right out of the data, right then and there. Similarly, if somebody had asked me a question during this, I would not have had to go spin up Kibana or something. I could just switch back to it. So yeah, that's the deck. If you want to play with Timelion, if you want to install it, there are instructions in the README on the GitHub repository. If you want to add stuff to it, I encourage you to. I've gotten a surprising number of pull requests for it, given that I really don't advertise it, and this is the first talk I've ever given about it. The functions are really, really easy to write. Basically, you're passed in a plain object with an array in it. You do whatever you want to the object and spit it back out at the end. Did anybody go to Elasticsearch this year? No? Hey, sweet. Well, David, obviously, you also went. You know that big like Ask Me Anything booth that they had at Elasticsearch? Like big thing. You walk up, ask the developers anything. I spent like a couple of hours just letting people walk up, and we would stand there and write functions together. It was great. I think I got three functions out, and we kind of just sat there and wrote them. At one point, I passed my keyboard to a coworker and said, "Here, you write the rest of it. I got to go do something." So yeah, there's Timelion. That's all I've got. If you've got any questions, happy to answer. Please don't throw any rotten fruit. Thank you. Questions, comments, baseless ridicule? Ridicule with a basis? No? Okay, well then, we're all done. Thanks.